Atoms, the building blocks of the universe. Welcome to chemistry. Hello everyone, my name is Miss Dennis and I'm so excited to teach you guys today about the tiny particles that make our universe possible. As we jump into this topic, I feel that it is important to first learn about the discovery of the atom, as well as some of the first developments in atomic theory. This will set us up to learn about the periodic table, as well as the evolution of the model of the atom. Around 2,500 years ago, the Greek philosophers Leucippus and Democritus founded the idea that matter, which is anything in the universe with mass, like a blade of grass or a gold ring, is made up of very small particles. They called these particles atomos, which means indivisible. This is because they had theorized that if you cut something in half enough times, you would eventually get to a small enough piece of matter, aka a particle, that could no longer be cut in half. These two philosophers were known for their great thinking, not so much for their data collection. There was not technology advanced enough to create concrete evidence for their claims, but they did lay down a foundation of curiosity about the world at an atomic level. To give a silly example, imagine a banana. According to Leucippus and Democritus' theory, this banana could be cut in half a certain number of times to achieve one particle of banana that could no longer be divided, the indivisible banana particle. Surprisingly enough, the next big developments in atomic theory didn't come around until about 2,300 years after the initial spark led by Leucippus and Democritus. In 1785, Antoine Lavoisier proposed the theory of conservation of mass, which stated that the shape or form of matter does not alter its mass. For example, 2 grams of ice which is left out on a countertop will turn into 2 grams of liquid water. No more, no less. And here's a picture of Antoine Lavoisier. In 1803, John Dalton, another chemist, proposed a model of the atom similar to the theory of Leucippus and Democritus's, which said that the elements, such as iron or gold, exist in small, solid packets of matter. According to Dalton, these packets could not be divided. And here's an image of John Dalton. In 1869, the world had a pivotal year for the development of modern chemistry thanks to the Russian chemist Dmitry Mendeleev. Mendeleev published a table in this year that would change the course of history. This table listed the mass of different types of elements and predicted the discovery of other elements based on similar physical and mathematical features. You may have heard of this table before. It's the one that we will use very often this school year called the periodic table. In the late 1800s, chemists began to ask themselves, what does John Dalton's model of the atom mean to atomic theory, the model that we talked about earlier with just one solid particle? Are atoms really solid pieces of matter that cannot be divided, or are they made of smaller pieces, such as in this, Thomson's plum pudding model? These smaller pieces, or subatomic particles, known now as protons, neutrons, and electrons, would be discovered in the near future, but we'll save this next model, called the plum pudding model by J.J. Thomson, for the next lesson.